Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Module 3, Protocols and Models. So the main focus of this is we're going to talk about the rules for communication, protocols, protocol suites, standards, and we're going to end with reference models and how all of this ties together with data encapsulation. So you're going to notice a big thing with this lesson is actually it's about understanding the importance and the role of communication and how the protocols and standards actually help facilitate that communication. Essentially, the rules for communication are those protocols and standards. So essentially, within communication, we're going to have a source, that's going to be the sender. We have a destination, that's going to be the receiver, and there's going to be a channel or a media that is used to provide the path for communication. So this is how basic communication functions. The structure of how to communicate is equally important. And that's going to be things like what language, what speed, how do we address errors, how do we address who's talking and who's listening. So that's where communication protocols come into play. Because essentially what we have to have is that structure. So communication is governed by, again, that structure. They are the rules. These rules will vary depending on which type of protocol we have. If we're dealing with human communication, we may have nonverbal protocols. We look at each other and we know not to be disrespectful, so we don't talk over one another. If one person is speaking one language, we speak that language. Well, with digital communication, it's not quite that simple. So we actually have to define rules. So, rule establishment. Basically, individuals must establish rules or an agreement to govern the conversation. These are formalized rules. If we don't have formalized rules, then we have issues. For example, here the first message is difficult to read because it's not formatted. There's not a lot of punctuation. It's also in multiple languages. Where with the second example, it actually is showing a properly formatted message with proper language understanding. So there's two types of rules. We're talking formalized rules and de facto rules. Formalized rules are agreed upon structured rules. De facto rules are rules because we've just always done it that way. They're not standard, they're just there because that's how we've done them. So protocols must account for very specific requirements. We have to identify who's going to send, who's going to receive. The structure with sending and receiving, so we can make sure that we do not talk over one another. Common language. Here, punctuation and grammar for talking, actual person-to-person communication. Speed, timing of the delivery as well. Error correction if necessary. If we are talking and something occurs, how do we recover from an error? I know error is not on the list, but that's also equally important. And lastly, confirmation or acknowledgement that we agree upon these rules. So, this is the breakdown for rule establishment. So, in network or digital communication, same very similar things have to be agreed upon. We have to talk about how it's going to be encoded and decoded. Talking about the formatting and the structure of it. The size of communication. How large of a chunk of data can we send on a media. The timing on the media. And are there delivery options? So let's go ahead and let's talk about message encoding. Basically, the encoding is the process of converting information into another acceptable form of transmission. Basically, if we're going to send it over the wire, how are we going to be able to send it over the wire and have the receiver take it, decode it, and be able to handle the message? Again, decoding is the reverse process of encoding. Encoding will be taking it and converting it, and then decoding will be converting it back. Next would be message formatting and encapsulation. So when there's a message being sent, there has to be a specific format, like when you're mailing a letter, source and destination and where the stamp goes. All of that plays an equal part in delivery. So here we have to look at the digital format, and they're called headers. Here we have a header for a packet. It lists things like the version, the traffic class, the flow label. That stuff's not as important, but that's part of the structure of that packet header. So as long as we understand that there is a structure for how we send the data, we are good. Message format will always depend on the type of message and the channel that is being used for delivery. If we are sending a datagram using an IPv4 packet, we're going to use an IPv4 packet header. If we're sending it using IPv6, then we have to use an IPv6 packet header. So there are slightly different rules depending on how we are sending data. Next would be message size. We have to make sure that the formatting is appropriate to the media and that the size is appropriate to the media. Because again, the message sent across the network has to be converted into a digital signal so that it can be sent across the media. The media being the actual wire, the copper cable, the fiber optic, or the wireless connection, things of that nature. So again, we may have to break this down into more manageable chunks. The message size may have to be smaller to make sure it fits on the wire. You cannot send a large package if the media cannot handle that size package. Moving on would be message timing. So message timing would include very specific action items: flow control, response time, and access method. The flow control will be the rate of transmission. How fast can we send it? The response time will manage how long the device waits when it doesn't hear a reply from the destination. Hey, did you get these 3 packets I sent? How long should I wait until I resend those 3 packets? And that's assuming error correction is there. So lastly would be access method, and this will determine when someone can send a message. If we have 2 people and they're talking at the same time, that's a collision. However, if we define who talks and who listens and the rules that govern that, that's going to be the access method. When we have 2 things talking on a digital network, it is still called a collision. And the collision basically forms a data corruption. The message doesn't get delivered because it was colliding with another message. It was corrupted. Next, we're going to have to talk about delivery options. So when we're sending a message on a digital network, even with people, are we sending it to a one-to-one? Are we sending it to a one-to-many? Or are we sending it to one to everyone? Meaning, if we're talking a personal communication, am I talking one-on-one? If I am, that's going to be equivalent to unicast. That is one message to one person. If we are talking to a small select group, maybe I want to choose everyone wearing sneakers, wearing a t-shirt, whatever criteria we select, and I want to send a message to them. That's going to be unicast. That is one to many, typically not to everyone. If I want to talk to everyone, that's going to be a broadcast. And again, that's one to everyone. Some things may show as icons. I've actually never seen this, but basically, if you're looking at this, one-to-one unicast, one to many would be multicast. Again, look at the arrows. And one to everyone would be broadcast. Moving on is our protocols. So the network protocols define the common set of rules, and that can be implemented on hardware, software, or both of them. And the protocols, each protocol may have their own function, formats, and rules. So we have a few different types of protocol types: network communication, network security, routing, and service discovery. Network communication will allow for one or more devices to communicate over a shared network. Network security will be securing the data to provide basic authentication, integrity, and confidentiality. That will be CIA: confidentiality, integrity, and authentication, or availability through authentication. Basically, you're going to verify who you are, you're going to make sure that the data is not modified in transit, and that it's held secure. Routing will enable routers to exchange information for path selection. And lastly, service discovery, that will be used for the automatic detection of devices or services on the network, assuming they can be automatically found. So again, these are just a few different protocol types and kind of their functions. In communication, in digital communication, as we grow, we actually have way more protocol types that exist. So when we're looking at the protocols, again, they each have their own functions: addressing, reliability, flow control, sequencing, error detection, application interface, and things of that nature. These basically allow devices to use the agreed upon protocol and the functions of that protocol. Not every protocol will have all of these. Some may have multiple, but not all of them. So it just kind of depends on, again, the protocol and what the protocol does. And again, like addressing is going to be identifying sender and receiver based off of a physical or logical. Reliability is about reliable connectivity or guaranteed delivery. Flow control is about how much we're sending and the efficiency rates. Sequencing will be like our numbering or our labeling. Error detection, that's pretty straightforward. And interface is going to be how we actually interact with one another. So, protocol interaction. How do the protocols interact with one another? So networks require the use of several protocols for communication. Here we have a 4-stack communication. We actually have HTTP. That's going to be the application protocol that we interact with. That's typically our web browser. We're going to have a transmission protocol, TCP. This will manage the individual conversations and manage flow. We have IP, and that's going to be used to send the data to an external source like a web server. And then we're going to have a physical access method known as Ethernet, and this will deliver the message from our network adapter to our router, and then from there it will be sent either via IP or Ethernet through our ISP to our destination, and so forth. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.